Hey everybody, it's Chris from Xano, and today we're going to talk all about securing your APIs in Xano. So you've built all these APIs in this amazing backend and you're ready to go, but maybe you're worried about the security of your backend. How do you prevent users from accessing your APIs outside of the context of your application? Today, we're going to talk about user authentication, so standard email and password authentication. We're going to talk about API keys, so maybe you don't necessarily have individual user accounts, but you still want your APIs to be secured via an API key. We're going to talk about reading the request headers and how you can utilize those in securing your APIs. We're going to talk about rate limiting, so preventing users from calling your APIs by just imposing a limit on how often they can be called over a specific time period. We're going to talk about combining some of these methods together. We're going to talk about some additional options at a very high level, just so you know what else is out there. And finally, we're going to talk about whether or not this matters. How much should you really care about securing your Xano APIs? So let's jump into Xano and let's take a look at our example project. So you can see here, we have a few API endpoints related to just a couple of database tables that we have for this example. We have our standard authentication endpoints, and we have endpoints related to two tables that we have, a data table and a user table. So let's talk about the first method of securing your API endpoints, and that is user authentication. User authentication is typically done by email and password, or maybe you're using a single sign-on solution, like a sign-in with Google or Facebook. Now, we do have those SSO methods built and ready to use in our Xano marketplace. For this example, we're just going to take a look at standard email and password authentication. So in our database, we have two users here, and over in the upper right-hand corner, we can go to the settings for this table, and this is where we're going to tell Xano, hey, this is the table that I'm going to use for authentication. So let's take a look at the three standard APIs, and we'll talk a little bit about what they do. So the first endpoint is our sign up endpoint. This API has three inputs, that is a name, an email, and a password. And in the function stack, the first thing we're doing is we are using these two steps to check to see if the user record exists. If the user does not exist, then we can proceed with sign up. But if the user does already exist, then we will return an error that says the account is already in use. We add the user record, and then we create an authentication token. And this is kind of where the magic happens. In standard user authentication, those requests require an auth token. That auth token is passed to your front end when a user either logs in or signs up. And that auth token is stored in a cookie or local storage or whatever makes sense for your app in that regard. When your user clicks on a button in your application that requires authentication, then your application will send that auth token along with the API request to Xano, so Xano knows that this is a user that is authorized to perform this action. So we create the auth token and we return that auth token in the response. So when the user is done signing up, they can begin to use the application right away. They don't have to log in again. The next endpoint is the login endpoints, which is pretty similar to the sign up endpoint. For this, we have two inputs, an email and a password. We are using the first two steps to get the record from the user table, and we're making sure that that actually returned a record. Does this user actually exist? If it does, we can continue. If we are not returned a user record, then that means that invalid credentials were provided. So whether the email or the password was wrong, this is the error message that will be sent. We then use a validate password function, and this function takes the input, so the password that the user provided when they were logging in, and it checks it against the password that is stored in your Xano database table. If these passwords match, which is determined by this precondition, then we create an authentication token just like we did in our sign up step, and we return that auth token in the response. The third endpoint that is created by default when you enable email and password authentication in Xano is this endpoint called auth.me. Auth.me is an endpoint that requires authentication, which is noted right up here at the top. It says authentication required. That means that for this API to actually proceed in execution, it needs to be provided an auth token, and that auth token needs to be valid. The only step in this function stack is to get the user record. So this endpoint is used in a couple of different ways. The first way is just an example of how authentication works. So we have our endpoint that logs in a user, or signs up a user, and then we have an endpoint that makes an authenticated request just to kind of show you what's happening. However, there are plenty of scenarios where you may actually utilize this endpoint in your application. For example, if you want to get the user data of the logged in user. So let's take a look at this in action. Let's go over to the login endpoint. I'm going to run and debug this, and I am going to log into my application. So I'll type my email and my password, and we'll click run. And we were returned an auth token, which means I can then take this auth token and I can use it in authenticated requests. So let's go ahead and give that a shot. Let's look at this auth me endpoint. So this endpoint requires authentication. So I'm going to run and debug, and I'm going to paste my auth token right here. We can click run, and then I am returned my user record as expected. Now let's talk a little bit about some of the customization that's available in securing your API endpoints. The first thing we're going to talk about is this expiration value. So you can actually choose how long before your authentication tokens expire. This value is in seconds, and the default is 86,400, which is 24 hours, but you can adjust this to whatever you'd like. If for some reason you would like to have authentication tokens that do not expire, you can just set this to 0, and then your tokens will be valid forever. Let's say you have users that have different roles in your application. Maybe some are regular members and some are administrators, which means they have access to a little bit more data. This extras parameter is an empty object that you can use for whatever data you would like. So maybe you want the user role to be stored in here. You can definitely do that. And then what happens is that auth token contains that data. So when we make authenticated requests against our APIs, those extras are included so we can check the user role and determine whether or not they're allowed to make this request. We're not going to get super into it for this example because we have some great resources available already, but just pointing it out, there is an additional layer here that you can employ if you're using standard authentication for your endpoints. So let's talk about using an API key. Maybe you don't have users that log into your application, but you still want to limit the access of your APIs in some way. You can do that by using an API key instead. So the first thing we need to think about is, how do we get the key? Well, realistically, the key could be anything you want it to be. In Xano here, I have a function that we can use to generate a key, which is right here under security functions. There's actually several that you could use for this example, but for this, we're just going to be using create secret key. So now what we can do is we can take this key, we can just click the copy button here, and we need to, of course, store this key somewhere so we can refer back to it. There's two places that you can store your keys. You can store them in your database table, or you can store them in an environment variable. And that's what I'm going to do today. So I just went over here to my settings on the left-hand side. I'm going to click manage under my environment variables. And I'm going to click this button to add a variable. And this variable is going to be called my API key. And I'm going to paste that in the value box right there. So now this variable is immediately available to us across all of our function stacks. So let's talk about how we're going to use this API key on one of our API endpoints. So for this example, I'm going to be looking at this get data API. This is just an endpoint, and we can run and debug so you can see exactly what it does. This just returns the data from our data table. So we need to build in a check to actually look for that API key in the request that's being made and determine whether or not we will actually return a result based on whether or not that key is provided. So the first step that we're going to add is a precondition, which is under utility functions. And a precondition allows us to check if something is true. If that thing is true, then the execution will continue. If it's not, then the API will halt and it will return an error message that we can actually define. So we need to click this pencil icon to define our condition. So on the left side of our expression, we are going to utilize our HTTP headers environment variable. Now we're going to dive a little bit deeper into how to use this variable, but essentially what this variable contains is all of the headers that come in with an incoming request to this API. An API request will always have headers, and they typically contain things like the format of the data that's being sent to the API, where the request is coming from, and of course, any authorization parameters that are required to run the API. Those are typically always included in the headers. So we are going to click the HTTP headers environment variable, and I'm just going to use dot notation. And for my example, we're going to dial down to the key called authorization, because that's what we are going to be using to provide our key from our front end. And we just want to make sure that this authorization value equals our API key. So we have that my API key variable, that environment variable that we defined earlier. So we're just checking to see if these both equal each other. So if they do, the precondition will continue. If they do not, then we can populate our error message. So let's just say unauthorized for our error message, and our error type will be unauthorized. So we can save that. So now this endpoint is checking for that API key. If the key is provided and it's correct, we'll continue. If not, then it will provide that error. Now this does make it a little bit trickier to test via run and debug. You can see here when I run this, we get an unauthorized because we're not defining that header. So it is good to temporarily either overwrite that variable in some way in the function stack. You can use the set HTTP headers function to do this, or you can just disable your precondition temporarily and just always assume that it's true for the sake of testing and debugging your function stack. I'm going to move my precondition to the top because I want that to execute first. And what I'm going to do is I'm going to publish my changes. And I'm doing that so I can test the API outside of Xano. So I'm going to copy my endpoint URL and I'm going to hop over to Postman, and we're going to send this request and we will see how it works. So here I am in Postman, ready to build my request. I'm going to paste my API endpoint URL, and I'm going to go over here to the authorization tab, and I'm going to click API key. And my key is just going to be authorization. And my value, we actually need to go back to Xano, and let's get that API key. And we will paste that in the value box. And that should be all we need to do. So we can click send, and you can see we are returned the data from our endpoint because that check was successful. We provided the API key that was necessary to actually make this request. Now, if we type whatever we want to in this authorization box and we click send again, you can see we get the error unauthorized because we did not provide the proper API key. For this next example, we are going to continue to use the HTTP headers environment variable, and we're going to look at some other values that we can use in those headers to further secure our API endpoint. So let's actually just take a look and see what's included in the HTTP headers. We are going to change our response here, and we're just going to return those headers instead. Let's go ahead and send another request from Postman. And we can actually see some of these headers that we have in our request. So what we have here is we have the encoding defined. We have a token that Postman sends. We have a user agent. We have our authorization header that we were sending earlier. We also have forwarded host, which is where we're sending this request. We have forwarded for and real IP, which is us, the client. Where is this request coming from? So there are several different things that we can work with here, and this will look a little bit different depending on what platform you're using to send your API requests. To show a practical example of how we can use this, we're actually going to use Webflow to make our API request. So for this example, we are using the Xano JavaScript SDK. A very simple implementation here. All we are doing is we are calling that getData API. Nothing is actually going to happen on the page. We just want to call that API from somewhere. So let's go ahead and open up this page. Nothing really happens on the page side, but we can go back to Xano and we should be able to see that request was just made. So here is our request, and we can take a look at the request headers here. And let's take a look and see what Webflow is sending us. So first we have our language and encoding, which is just defining some information about the data that is actually being sent and received. We have our referrer, which is where this request is coming from. This is the first value that we're actually going to take a look at for this example. So we can see here that in this referrer value, we have our webflow.io domain here. So what we want to do is we want to check this referrer to make sure that these requests are only coming from exactly where we want them to come from. And we are going to do that in a very similar fashion to how we performed the authorization with the API key. We just need to change the value that we're looking for in the headers. So that is going to be refer. And let's grab our webflow.io URL here. And we can just paste that in the right-hand side of our expression here. So that really should be all we need to do. So we can go ahead and save this. Let's enable our precondition and publish our changes. And now let's go over to Postman. Let's see what happens when we make this request. You can see we get an unauthorized because Postman is not providing the correct referrer value for us to actually continue with this request. But if we go over to Webflow and we refresh our page, so now we're going to look at the request history, and what we should see is we should see two requests. We should see this unauthorized request right here. This is the request that came from Postman. And we know that because, of course, we can see the user agent is Postman, and we kind of know what we're looking for there. But if we go back, we can see that the request right after was a success. We were able to proceed with the execution of our function stack, which right now just returns that HTTP headers value. And we can look in those request headers and we can see that referrer matches what we have defined in our precondition. So what we've done is we've locked down our API so that requests can only come from our actual domain. You can use this same method, and you could even combine multiple values in your headers if there are maybe a few things that you want to check before you actually proceed with execution. Maybe you want to lock down your APIs so requests can only come from specific IP addresses. You can do that by looking at the forwarded for and real IP headers. Maybe you want requests to only come from a specific user agent, like a mobile application that you're deploying. You can define the user agent in that way. Now we're going to try something a little bit different. We're going to talk about rate limiting. If you've been working with APIs for any period of time, you are probably very familiar with the concept of a rate limit, which is essentially something that says this API can only be called this many times within a certain period of time. What rate limiting will allow us to ensure is that if a bad actor is somehow able to navigate past all of the other obstacles that we have in place, and they're able to make those calls to our APIs outside of our application, we can at the very least limit the amount of times that they're able to call that API within a period of time, which will give us an opportunity to mitigate any damage that may be occurring because of this. So let's look at how we can implement a rate limit inside Xano. The rate limit function is under the data caching section. So we'll click on rate limit. It's all the way down at the bottom. And so we have a couple of options here. We have a key, our max, our TTL, and an error. So for the key, we're just going to use test. Our max is how many requests can be made within the duration that we specify. So for this example, we'll just use 5. So this means we can make 5 requests every 60 seconds currently. The TTL is the period of time in which this amount of requests can be made. So we'll just keep this at 60 seconds. And we can also define an error. Now there's 2 different ways that you can kind of utilize this. So if we define an error here, if I type in an error message, the rate limit will be automatically enforced. Once the rate limit has been hit, this error message will be returned and the endpoint will not execute. So let's take a look at that first. I'm just going to type rate limit exceeded, and we'll go ahead and save this, and let's publish our changes. And we would actually want to make sure that the rate limit is at the very top of the function stack. So we'll do that. And now we'll go over to Postman and let's see if we can trigger that rate limit. So we'll go ahead and send a request. Another 3, 4. So there's our 5th request. So now when we hit send again, you can see we are returned our rate limit error. So this means that we will have to wait for that 60-second timer to expire before we can perform another request to this API. Now let's say maybe we want some specific logic to execute if the rate limit is actually hit. So we can clear this error. And what I'm going to do here is I'm going to change my response so it returns that rate limit 1 variable. And I'm going to go ahead and publish my changes. And what this will demonstrate is how we can actually utilize the output variable of this rate limit step. So we can go ahead and send a request. You can see we get a true, another request, number 3, number 4, and number 5, and finally we get a false. So what this variable contains is a true if the request is allowed, and a false once we hit that rate limit. So we could easily implement a conditional statement here to check to see if this rate limit is false. Maybe you want to record in a database table some information about the request that's being made before you actually halt execution. You can implement something like that, may be useful for you. The point is you have some flexibility in what happens when that rate limit is actually hit. So we've looked at several different ways to secure your API endpoints. We've looked at user authentication, API keys, looking at the request headers, and finally now rate limiting. If you want to get really serious about securing your API endpoints, we can combine these methods in several different ways to implement multiple levels of security. So in our API here, we have the rate limit set, but let's say we also want to utilize an API key. So we can go back to our utility functions and we can add a precondition. And just like before, we're going to check our HTTP headers.authorization variable. And we will make sure this equals our API key in our environment variables. So we'll go ahead and save that. Let's set our error message and we'll hit save. And let's move this to the top. We want to first check the API key and then we want to verify the rate limit. And let's go back over to Postman. We can send a request and you can see we get our unauthorized message. So let's go ahead and set our API key. And let's send another request. So it looks like that was successful. So we get our true. And if we send a few more requests here, you can see we now get a false, which means we've hit that rate limit. But of course, if we do not provide a correct, we don't even get to the point of checking the rate limit. We're just immediately unauthorized and execution cannot continue. As a more practical example, maybe we want to check to make sure that users can't spam the refresh button on our site and perform that many requests in a specific amount of time. So we are going to change from checking our API key to checking the refer. And let's get our URL. And we'll go ahead and save that and publish our changes. So now what we're going to do is we're going to go over to Webflow and we're just going to refresh the page 6 times. And what should happen is we should have 5 successful requests, and then the 6th request will hit our rate limit, and we'll see that false in our request history in Xano. So we can see our first request returns a true, our second request returns a true, and all the way up to our 5th request, which returns a true. And we should be able to refresh one more time. And we can see that that request returns a false, which means we have hit our rate limit. If we go over to Postman and we send a request, we get an unauthorized right away because, again, Postman is not sending the referrer value that Webflow is, which is what we're also checking in the function stack. So we've implemented both the rate limit and the referrer check. We could even combine this with user authentication if we wanted to. So let's go ahead and enable authentication on this endpoint. We'll publish our changes. And let's go ahead and get a user auth token, which we will grab right from Xano here. So we've copied our authentication token. Let's go over to Postman. And we will set a bearer token. So we'll paste that auth token in there. Send the request, still unauthorized because Postman is not part of that referrer. But if we go over to Webflow, we just need to make a small modification to our code. So we're going to add a new line to our code to set that auth token. And we'll save, and let's go ahead and publish that. So now we have user authentication, a rate limit, and a referrer check all in place. And we'll go back to our published page, we'll refresh, and we'll go back to Xano and we'll check that request history, and we should see an authenticated request. So we can see here is our latest request, and we have an output of true, which means we are successfully passing the referrer check, the rate limit check, and we have provided proper user authentication to access this endpoint. So now that we've talked about several different ways that you can secure your API endpoints in Xano, let's talk about some additional options. There are additional services that you can utilize outside of Xano with your Xano APIs to make sure that they stay super secure. Now, using these methods are unfortunately way outside of the scope of this video, but I do at least want to make mention of them so you know what options you have available to you. And these would be services like Pong, Teak, Zool, Cloudflare's API Shield, or Apigee from Google. These are API gateways or API proxies that allow you to essentially have a middleman in between your application and your Xano APIs. So if you're interested in some really serious high-level security measures for your APIs, I definitely recommend exploring some of these options. This is the part of the video where I would really love to hear from you, so definitely make sure to leave a comment down below. I would love to hear about the measures that you are taking to secure your APIs that you build in Xano. I think this will be really valuable for others that are stumbling across this video and would maybe just love some additional input into the final topic of our video, which is this something that you really even need to do? Do you need to stress about locking down your APIs in as many different ways as possible? And the answer is it really depends. What type of application are you developing? Is it a tool that is internal to maybe just your organization, or is it an external public-facing application? What makes the most sense for your application? In my opinion, standard user authentication is going to be one of the best implementations that you can build. Because that authentication is specific to each user, there's not ever going to be a way for a bad actor to come in and have a token that they can use to access your APIs. They have their own token that they received when signing up and logging into the application, but provided your APIs check and return only data that belongs to the authenticated user, they will not ever be able to touch another user's data. Now, if you're not using user authentication, which means that you maybe have a little bit more of an open platform, you should absolutely be exploring rate limiting, checking the headers, and potentially even one of the third-party services that were mentioned earlier to make sure that all of your bases are covered in terms of security. Your own internal practices are also going to be super important here. How often do you actually monitor the requests that are coming into your application? What practices do you have in place to make sure that everything is running as it should? A huge part of making sure that your backend stays secure is monitoring what's actually happening on that backend and having a plan in place if something goes wrong. So while all of the methods that I've mentioned in this video are valid and very important, especially when used in combination with each other, it's just as important to make sure that you know what's going on and you know what to do if something that you need to address occurs. I know this is a topic with a lot of nuance and everyone is going to have an opinion. I'm certainly not a security expert, so I would love to hear from you about what you're doing to secure your APIs and any questions that you have. So please make sure to leave a comment down below. You can also reach out to us via the Xano community or through support chat inside Xano. Thanks so much for watching, and we will see you in the next one.